Okay. So today we're starting, other than limits, I know we were talking about limits. That is one part of calculus. Today we're starting on the very main topic of calculus. So today is the 6th, right?
Yes.
Okay, thanks. 11:6. You can't see that color. See that one now? 24. Today we're going to be talking about rates of change and calculus. Rates of change and calculus. Before we get into the actual, Brian, you can like physically turn the desk if you need to. Okay. Before we get into actual calculus terms for this, we're going to need to review some vocabulary because, like I said before, calculus encompasses all of our skills, all of algebra, all of geometry, all of algebra 2, your freshman, sophomore, junior year. And we need to know those before we move on to actual calculus. So the first one is slope. We reviewed slope in the do now. Slope, the definition, is this value, and please stop me if I'm going too fast, that describes the steepness of a line. This is also called, we're going to need to use all of these definitions, also called, I can't spell today, also called the rate of change, the unit rate, or the rate. These are all different phrases or words that mean the same. It means slope. Am I going too fast? Okay. We have a formula that we've seen before. We saw it in the do now. The formula is y2 minus y1 over x2 minus x1, where we have two coordinates. But a lot of times in calculus, we're not going to be given just the coordinates. We're going to be given a graph. We're going to be given a function. So in can I move up just right there? Okay. Steven, you good right there?
Yeah.
Morning, Freddie. So in calculus, we're going to be doing something that looks like this. Delta x, thank you, over delta y. Does anybody know what delta stands for in math?
The change.
Ooh, who was that? Who said the change? Yes. Can you write her down for merits, please? Yes, delta means the change. The change of. Ooh, wait, I messed up. Can somebody tell me where I messed up? Anybody know? That's okay. Y was supposed to go in the numerator. I pulled some of your mistakes. Sorry. Delta y over delta x. Yes, so we're looking for the change of y divided by the change of x. So you're going to see this a lot when we're doing notes. Okay, delta. Delta means the change. We're going to be using that mathematical vocabulary in calculus. Also in calculus, we're going to be using this formula f of x2 minus f of x1 over x2 minus x1. And this is if you have a function instead of coordinates or graph. And yes, we're going to need to know how to substitute in to evaluate the function. Can I move up there? Right there? Okay. Okay, that's it for slope. We have a few more review vocabulary. Y-intercept. Does anybody remember what the y-intercept is? Definition? Nobody? Bueller? The y-intercept is the point where a graph crosses the y-axis. The coordinates are 0, c. That's 0. I'm just going to cross that out for 0. So you know that's a 0, not an O. Going too fast? Okay. If that's the y-intercept, can anybody derive the definition of the x-intercept? If the y-intercept crosses the y-axis, what do we think the x-intercept does? Very good. Actually, it could be multiple points. So we're going to say the point or points where a graph, thank you, Joaquin, crosses the x-axis. That has coordinates, excuse me, of a, 0. So for the intercepts, there will always be a 0. All right, and then the last vocabulary review word is slope-intercept form. Can anybody remember what slope-intercept form of a line is? Nobody? Nobody? That's okay. That's why we're reviewing. Y equals mx plus b. But in calculus, we use c. And we'll figure out, or we'll learn why we use c later. Okay? So b is c. We're going to be using c in calculus. C in calculus. Which of these variables is the slope? Very close. Not the mx, because the x is a variable. It's just m. Okay? So slope is your m value. Then what is your y-intercept? Very good. Everybody have these down? Who came in late? Oswaldo? You need this then, right? Okay. Can I go? Can I move? Are we good? Okay, nobody said anything. Okay, now we have gone over the review vocabulary. We're gonna go over the new vocabulary. So this is new vocabulary. This is new vocab. Gentlemen. Our new vocabulary word is called, or phrase, average rate of change. Average rate of change. The average rate of change is the rate of change. Can you see this color? Thanks. Over an interval of a curve, graph, function, whatever. Ms. Santana, what's an interval? Glad you asked. An interval is a range of numbers. So in this case, it's going to be a range of x values. So the interval is a range of x values. But why does this matter? Isn't slope the same for everything? No. Slope is not the same for everything. The only thing it's going to be the same for is a straight line. But we might not have straight lines in calculus. We have tons of different functions, tons of different graphs that we can use in calculus. So it's not always going to be the same. So I'm going to abbreviate it as average rate of change. May not be the same value. Over all intervals. It can be, but it might not be. Can I move up? So let's say I have, let's see if I can do this. What is my, okay. So let's say I have this function. Morning. This is not a straight line. This is actually called a 4-degree polynomial. The slope on, let me use a bright color. Yeah. The slope over these 2 points, this interval, will not be the same as the slope or rate of change between these 2 points. That is why we need the average rate of change between two things if we're studying these functions. It's not going to be the same. You can see that this is going to be negative and this is going to be positive. So it won't be the same. Okay. We're almost done with notes and then we'll get to the examples. Are we ready? Angel? Good? I can see other people still writing. Ivan, are you awake? Okay. Steven, let me know when you're ready. You ready? Anybody else writing this one? Whoa. Is that Justin's seat? I mean, Freddie's seat?
No, but you can't see.
Oh. Gotcha.
So just temporary.
Okay. Okay, I can move this? Okay. So we're going to talk about level 1 examples. So remember, I'm always going to give you the different ways they can appear on your assessment. So this is level 1. Level 1 is going to be finding rate of change. Or I'm sorry, average rate of change with graphs. Oops, I don't know why I put that line in there. Or functions. That's where the line should go. Sorry. So what we're talking about today will be level 1. Oops. So I'm going to give you the steps on how to find these, and then we'll go over examples. So your first steps, is to find the coordinates. You're going to need 2 coordinates. You're going to need x1, y1, and x2, y2. Remember that we're going to be given the x's. We just need to find the y's. So if we have a graph, we need to find the coordinates, find the points. If we have a function, am I going too fast? We need to evaluate, and you'll see what I mean in a second. We're going to evaluate to find the y value if we have a function. That is your first step. And we've been evaluating. When we were doing level 2 and level 3 of finding algebraic limits, or finding limits algebraically, we substituted in those numbers. That is evaluating. Substitution is just evaluating. Step 2 is then you're going to use the slope formula. And we have that all down. And step 3, you're going to simplify. We want reduced fractions. We'll tell you when there's a decimal if it involves a square root or a cubed root, but that won't come until later. Okay. When you're done copying this down, take out that example sheet that I passed out. Mr. Lowe, I don't know who needs this.
Oh. no shade.
Okay.
Once you're
Daisy?
done taking notes, you can go back. My God.
Victoria?
I just do.
Okay. What? Okay. Are we ready? Is he ready? Justin, pass that to Daisy, please. All the way in the back. All the way in the back. Okay. Ready? Ready? Okay. All right, let's look at example 1. These are all level 1s. These are all level 1. Okay. So I have a graph here. So I'm going to look for my coordinate. What did I say these numbers in the brackets stand for? Not parentheses, brackets. These are different. This bracket involves an interval. This implies intervals. What part of the coordinate are these? The x's, good. So this is going to be x1 and x2. So I'm going to go onto the coordinate, or go onto the graph, and I'm going to find out where -1 is. -1's here. So I need to write my coordinate. I have -1, comma what? What is the y value for this coordinate? 1. Does everybody see that? Snaps your hands. Okay. So then what's my next x value? So we have -1 as my first. Here's x1. Yes, 0. So 0 is my next x value. 0 is here. What is the y value for 0? 1 also. Snaps your hands. So this is y1 and this is y2. What do we do then? Let's use mathematical terms, not plug in. Starts with an S. Substitute. What'd you say? Are we ready? Okay, so now we're going to substitute into our slope formula. We have y2, which is 1, minus y1. Can you guys see? Over x2 minus x1. Questions? Going too fast, too slow, just right? And now I'm going to put this into the calculator. So you would put it in the calculator, and when you put it in the calculator, you would get 0. This is your average rate of change, 0. I'm skipping the calculator part. Skipping the calculator part because we should all know how to put in fraction in the calculator. How do we put a fraction in the calculator? Very good, Joaquin. Alpha, y equal. Questions? Are we sure? Snaps, hands. I think we're going to need to leave like some of these lights on. I'm going to skip letter B for sake of time, but it's the exact same thing. You find the coordinate, substitute it into the formula equation, slope equation. Let's move on to C. Okay. Do I have a graph for C? No, this is a function. So because we have a function, we need to find the y value. We need to find the other part of the coordinate. What did we say these were, everyone? Intervals, yes. But what are the values on the inside? X's. So these are x1, as Joaquin was saying, and x2. So I need to substitute in each of these separately. Substitute. We're going to substitute these into the function. So my first x1 is -1. I'm going to substitute it in for t. So I get negative 1 squared plus 1. Are there any questions on that? Give you processing time. Okay? When you put that into the calculator, you get, hold on, let me find my answer key. You get 2. So now this is my y1. So I can create a coordinate with negative 1, comma 2. Is he in the same seat?
Yes.
Okay. Questions? So now we'll do the same thing for x2. We'll substitute in 0. Where are we substituting 0 for? T. So it's going to be 0 squared plus 1. When you put it into the calculator, you get 1. So this will give me what coordinate? Not y1, y2. We already have y1. Snaps her hands. Ooh. For those of us not snapping, are we just still writing down? Thank you, thank you. Okay. Now we have our 2 coordinates. 0, comma 1. What do? We just leave it like that? What are we trying to find? Thank you, average rate of change. So how do I find the average rate of change if I have my 2 coordinates? What do I use? Look at your steps. Look at your steps. Number 2. Yeah, we use the coordinates for what? But what specifically do we use? Look at your steps. Number 2. Nope. You're using the wrong formula, Joaquin. Slope formula, okay? Remember, slope formula and slope-intercept formula are 2 different things, okay? So we're going to use the slope formula. Remember, slope formula is y2 minus y1 over x2 minus x1. I guess I should have said that in the first example. y2 is 1, y1 is 2, x2 is 0, and then negative 1. Questions? When you substitute that or plug that into your calculator, we get negative 1. Snaps hands. Thank you, Lucero. Thank you, everybody, for snapping. Am I going too fast? Are we sure? Don't sound so disappointed. Okay. I don't understand what it is with students nowadays, but you get so afraid if there's a fraction, if there's a decimal. Math is not perfect. There are going to be negative numbers. There are going to be large numbers. There are going to be decimals. There's going to be square roots. There's going to be, it's numbers, okay? All we care about is that it makes sense. We're talking about the make sense part when we start doing word problems. But we have a fraction here. This is called a rational function. It's okay to have a rational function in calculus. Not everything's perfectly linear. We still follow the same steps. We're going to substitute in to find my coordinates, and then we're going to evaluate using the slope formula. So this is x1, and this is x2. Any questions on that? Same process. It's just a rational function. Same process. What do I do with 0? Substitute it in for s. Very good. So it's going to be negative 1 over 0 plus 2. How do we put a fraction in a calculator? Alpha y equals. Alpha y equals. If you don't know that, put it in your notes now. Alpha y equal gives you a fraction bar. Okay? When you put this into your calculator, you will get negative 1/2. That means what my coordinate will be what? What does this stand for? I heard somebody say it. Y1. So what is my x1? Nope, not 2. What are we substituting in? 0. Okay? That's why labeling is important. You should be labeling. Label everything. Label everything. So now that I have my x1, y1, how do I find my x2, y2? Morning, Bagel. How do I find x2, y2? Substitute 1 for s. So I have negative 1 over 1 plus 2, and that gives me negative 1/3 if you put it in the calculator. Which means that my coordinate is what? 1? Negative 1/3. Very good. That is my coordinate. So that is x2, y2. And then what do I do with that? I heard somebody whisper it. Substitute to what? Do I just substitute it back in for s? Look at your notes. What are we using? The slope formula. So I'm going to substitute this into my slope formula. I have negative 1/3 minus negative 1/2. Seniors, don't forget to put it in parentheses. Don't forget to put it in parentheses because you're going to get a completely different answer. Divided by 1 minus 0. How do we put a fraction in calculator? Alpha y equals. Bless you. When you put that in the calculator, you should get 1/6. When you put that into the calculator, you will get 1/6. Questions? Are we sure? Okay. Then if you're done copying this down, flip over your paper. I know we only have 5 minutes left, but that 5 minutes is enough to get number 1 and 2 complete. That 5 minutes is enough to get number 1 and 2 complete. You should be working in your groups at a level 1. Tomorrow we will be going over doing more practice, and you will have an exit ticket at the end of class. Okay? Questions? Alrighty.